Good morning all. So in today's class we will be taking up the topic electron gain enthalpy. First of all, here why don't we use the word energy? Because enthalpy is the energy that is measured at the constant pressure. Because enthalpy is the energy that is measured at the constant pressure. So, electron gain enthalpy is the amount of energy released. When one electron is added to isolated gaseous atom to form isolated gaseous anion. And it is represented by delta EgH, where H is enthalpy and Eg means electron gain. So, since this value is written on the product side, that means energy is released, which means this would be a negative value. Whenever energy will release, the value will be negative. Like in ionization enthalpy, we need energy to remove the electron. So, energy is positive in case of ionization enthalpy. Now, what do you think? Which kind of atom gain electron easily? That is non-metal. Non-metal gains electron to complete its octet. So, its electron gain enthalpy will be high. That means more negative value of electron gain enthalpy. Higher value means more negative value. And metal has a tendency to lose the electron. So, they will going to have less negative value of electron gain enthalpy. Whereas, noble gases neither gain electron nor lose electron because of their stable electronic configuration. And due to this, they have highly positive value of electron gain enthalpy. Higher positive value of electron gain enthalpy. Positive value means lower value of electron gain enthalpy. Negative value means higher value of electron gain enthalpy. Positive value means lower value of electron gain enthalpy. Now, let's see variation across a period. Now, as we know, when we will move left to right across the period, the atomic size decreases and force of attraction between the electron and the nucleus will increase. Therefore, electron gain will be easy. Electron gain will be easy due to increase in force of attraction. If electron gain will be easy, which means electron gain enthalpy will be more, means more negative. Also, when we will move left to right across the period, non-metallic character increases, which means it have a tendency to gain the electron, and directly we can say the electron gain enthalpy will increase, means it will become more negative. Down the group. As we know, when we will move down the group, the number of shells increases, and due to increase in number of shells, the force of attraction between the electrons and the nucleus will decrease. And due to decrease in force of attraction, the tendency to attract the electron will also decrease. So, the electron gain will be difficult. In this case, the electron gain will be difficult. And electron gain enthalpy will decrease, means it will become more positive, or you can say less negative. Now, the next is successive electron gain enthalpy. Successive means again and again. Successive means again and again. Like in ionization enthalpy, when we have removed one electron, then that energy is known as first ionization enthalpy. For second, it is known as second ionization enthalpy. For third, it is known as third ionization enthalpy. So like this, if we have neutral gaseous atom and it gain one electron to form isolated gaseous anion, and the energy which is going to release is known as electron gain enthalpy. Now, if we will add one more electron in this, then during the addition of one more electron, there will be the repulsion between the negative charge and the electron due to the same charge on the anion and the electron, and same charge repel each other. So, to overcome this repulsion between anion and the negative charge of incoming electron, it needs energy, which means successive electron gain enthalpy will always be going to positive. Why positive? Because as you can see, anion is having less number of protons and more number of electrons. Due to the presence of less number of protons and more number of electrons, the effective nuclear charge decreases. And due to decrease in effective nuclear charge, the force of attraction will also decrease. Now, it will be difficult to attract incoming electron. So, it will going to require push to attract electron, and push requires energy, which leads the value of electron gain enthalpy positive. For example, oxygen, atomic number of oxygen is 8, means it is going to be 1s2, 2s2, 2p4, or you can say 2 or 6. Now it needs 2 electron to complete its octet. So, when oxygen gain one electron, and that time the energy which is released is known as first electron gain enthalpy, and it will form O negative, which means 2, 7. And the electron gain enthalpy will be negative. Now, if this O negative will gain one more electron to complete its octet, then due to the presence of this negative charge, or due to the presence of the negative charge on the electron, there will be the repulsion between the O negative and the electron. So, the attraction or the addition of electron will be difficult. Then it will going to require the push to attract the electron, and that push requires energy, which leads the value of electron gain enthalpy positive. Now, let's discuss factors affecting electron gain enthalpy. So, first factor is atomic size. As you all know, as the size of the atom increases, the force of attraction between the electron and the nucleus will decrease. And due to decrease in force of attraction, it will be difficult to attract incoming electron. So, electron gain enthalpy will decrease, means it will become less negative. Second is nuclear charge. As the nuclear charge will increase, force of attraction between the electron and the nucleus will also increase. So, electron gain enthalpy will also increase, means it will become more negative. Third is electronic configuration. The element who is having exactly half-filled or completely fully filled electronic configuration are very stable. As a result, the energy has to be supplied to add an electron. Because of their stable electronic configuration, we need to supply energy for the addition of electron. So, the electron gain enthalpy will going to be decrease, means it will become more positive. Now, let's do few questions based on this topic. So, first question is, why alkali metals possess less negative value of electron gain enthalpy? Now, as you know, alkali metal is having the largest size as they lie on the left side of periodic table. So they have largest size. So due to the largest size, the force of attraction between the electron and the nucleus will decrease. And due to decrease in force of attraction, they have a little tendency to accept the electron. So electron gain enthalpy of alkali metals will going to be less negative. Second question, arrange the following elements in order of their increasing order of first electron gain enthalpy. And the elements are boron, nitrogen, carbon, oxygen. Boron is having atomic number 5 and the electronic configuration is 1s2, 2s2, 2p1. Nitrogen is having atomic number 7 and the electronic configuration is 1s2, 2s2, 2p3, which is half filled electronic configuration, means it is stable. Electronic configuration of nitrogen is stable. Carbon atomic number is 6 and electronic configuration is 1s2, 2s2, 2p2. Oxygen atomic number is 8 and the electronic configuration is 1s2, 2s2, 2p4. As you can see in this element, only nitrogen is having half-filled electronic configuration, means stable electronic configuration. And as you know, in the stable electronic configuration, it is very difficult to add the electron. So, the electron gain enthalpy for the nitrogen will going to be less. And now, boron, carbon, oxygen, as they belong to same period, and as you know, left to right, the electron gain enthalpy will increase. So it will be boron, then carbon, then oxygen. Next question is, why halogen have the most negative value of electron gain enthalpy? Now, as you know, the outer electronic configuration of halogen, that is Ns2, Np6. As a result, they have strong tendency to accept the additional electron. Hence, their electron gain enthalpy value will be highly negative, means it will going to be very, very high. Next question is, why electron gain enthalpy of fluorine is less negative than that of chlorine? As you know, when we will move up to down in the group, there will be increase in size, and due to increase in size, the force of attraction between the electron and the nucleus will decrease, and due to decrease in force of attraction, there will be the little tendency to attract the additional electron. So according to this, chlorine should have less negative value of electron gain enthalpy, but in this, fluorine is having less negative value of electron gain enthalpy than chlorine. This is due to the small size of fluorine. Due to small size of fluorine, there will be the electron repulsion. There will be the more electron repulsion, whereas chlorine is having larger size than fluorine. So electron repulsion will be less. Thus, electron gain enthalpy of fluorine is less negative than chlorine, just because of the electron repulsion. Our next topic is electronegativity. Electronegativity is the tendency of any element to attract shared pair of electron towards itself. It is a tendency of any element to attract shared pair of electron towards itself, and it is represented by chi. Like ionization enthalpy, electron gain enthalpy, electronegativity cannot be measured directly. The electronegativity of any element is not constant. It varies depending on the element to which it is bonded. Across a period, as we know, when we will move left to right, the atomic size decreases, and due to decrease in atomic size, the force of attraction between the nucleus and the electron increases, and due to increase in force of attraction, the electronegativity will also increase because it is a tendency to attract the shared pair of electrons. But as we move up to down in the group, the atomic size increases, and due to increase in atomic size, the force of attraction between the nucleus and the electron decreases, so electronegativity will also decrease. Now let's do factors affecting electronegativity. First is atomic radius. As you all know, as the atomic radius will increase or atomic size will increase, the force of attraction will decrease, and due to decrease in the force of attraction between the electron and the nucleus, the electronegativity will also decrease. Second, effective nuclear charge. If the effective nuclear charge will be more, then force of attraction between the nucleus and the electron will be more, and due to increase in the force of attraction, the electronegativity will also increase. Third is oxidation state. Oxidation state means charge on the ion. If oxidation state or charge on the ion will be more, then electronegativity will be more. For example, Fe3 positive will going to have more electronegativity than Fe2 positive. Fourth is hybridization state of an atom. If the S character in the hybridization state of an atom is more, then electronegativity will be more. For example, the hybridizations are sp3, sp2, sp. In this sp3, the S character is only 25%. In sp2, the S character is 33.3%. And in sp, the S character is 50%. So, the electronegativity of sp will be high because of the presence of more S character. Now, let's do our next topic, that is application of electronegativity. So, first application is it tells us about metallic and non-metallic character of atom. More is the electronegativity, more will be the non-metallic character, because non-metals have strong tendency to attract the electron, and due to this it will going to have more value of electronegativity. Second, polar or non-polar bond. If the difference in the electronegativity between the two bonded atom is more than the bond is polar. If the difference in the electronegativity between the two bonded atom is more, then it will going to be polar. But if the electronegativity difference is less or zero, then the bond is non-polar. For example, the two bonded atoms are HF, HCl, HBr, HI, and the bond between them are polar, because of the large difference between the electronegativity of two bonded atoms. Because one belongs to group 1 and other belongs to group 17, and there is a huge difference in the electronegativity. So the bond between them is polar. Whereas H2, Cl2, N2, O2, they all contains same atom. So the bond between them are non-polar because both the atoms are same and the electronegativity difference is 0. Now let's do our next topic, that is periodic trends in chemical properties. So till now we have studied that periodic properties play a key role in the study of chemistry of different elements and their compounds. Moreover, these properties also affect the chemical behavior of the elements to large extent. However, most of trends in chemical properties like diagonal relationship, inert pair effect, lanthanoid contraction and its effect will be discussed later along with the study of chemistry of different blocks. Here we will study only some of the chemical properties. So first is metallic and non-metallic character. As you know, metals are formed by the loss of electron and non-metals form by the gain of electron. So in general, on moving top to bottom, the metallic character increases, and on moving left to right, the non-metallic character increases. Why this is so? Because as we will move left to right in the period, there will be the small size of atom, and due to small size of the atom, the force of attraction between the electron and the nucleus will increase, and due to increase in the force of attraction, the tendency to attract the electron will also increase, so non-metallic character will increase. Whereas metallic character increases on moving top to bottom, because as we will move top to bottom, the atomic size increases, and due to increase in atomic size, the force of attraction between the electron and the nucleus will decrease, and due to decrease in force of attraction, they have a more tendency to lose the electron. They can easily lose the electron, so metallic character increases. While in general, S-block elements are all reactive metals. D-block elements are all metals having high value of melting point, and their reducing character is less than F-block elements. F-block elements are heavy elements. P-block elements contains both metals as well as non-metals. 80% of the total elements known as metals. Mercury is the only metal which is present in the liquid form. Non-metals are generally present in the gaseous or solid form, while bromine is the only non-metal which is present in the liquid form. Next is valency. Valency is defined as the combining capacity of element. The valency of an element is related to the electronic configuration of its atom and usually determined by electron present in the valence shell. On moving along a period from left to right, the valency increases from 1 to 4 and then decreases to 0 for noble gases. While on moving down a group, the valency remains the same. However, nowadays the term oxidation state is more in use as compared to valency, and it is defined as the charge acquired by an atom on the basis of electronegativities of other atoms in the molecule. The charge acquired by an atom on the basis of electronegativities of other atoms in the molecule. From the valences of the element, it is possible to predict the formula of the compound formed by them. For example, if we have element beryllium and chlorine, and we want to know the formula of the compound formed by these elements, then first of all we have to find their valency. As you all know, beryllium belongs to group second, hence its valency is 2. Chlorine belongs to group number 17 and its valency is 1. Then the formula of the compound obtained would be BeCl2. Now our next topic is anomalous properties of second period of elements. The first member of each group of the respective element, that is group 1, group 2 and group 13 to 17, differ from the other members of their respective groups. This anomalous behavior is because of their small size, large charge to radius ratio, third, high electronegativity, and fourth is absence of d orbital. Due to these four anomalous behavior, the first member of each group differ from the other member of their respective groups. And it is observed that these elements show resemblance in their properties of third period lying along the diagonal line. For example, lithium show resemblance to magnesium. Beryllium show resemblance to aluminium. Boron show resemblance to silicon. Such type of resemblance in properties of elements lying along the diagonal line in periodic table is known as diagonal relationship, and it is due to the same polarization power. Now, what do you mean by polarization power? Polarization power means the ability of a cation to attract the electron cloud towards itself. Again, it is the ability of a cation to attract the electron cloud towards itself. So, polarizing power is proportional to charge by size ratio. Now, let's do one or two questions based on this topic. So, the first question is why boron can form only BF4 but not BF6, whereas aluminium can form AlF6. So, the simplest answer is because boron doesn't have vacant d orbital, whereas aluminium have vacant d orbital. So, boron can form only BF4. Or you can write because of the 4 covalency of boron. And what do you mean by covalency? Covalency is the number of electron pairs an atom can share with other atoms. So boron is having 4 covalency. So it can form BF4, whereas aluminium covalency is 6. So it can form aluminium F6. The next question is, are the oxidation state and the covalency of aluminium in aluminium Cl H2O6 2 positive same? As you all know, the oxidation state of aluminium is +3, but the covalency of aluminium is 6. So the oxidation state and the covalency of aluminium is not same. I hope you have understood today's topic. So that's all for today. Have a nice day ahead.